graph, vertical axis. Okay, so graph the equation. Well, let's put our equation back up there. So that's h equals 40t plus 300. And this was all in meters. Okay, also let's put back up here, this was our x and this was our y. So this was t and this was our height. Okay, that way we know where our axes are going to be. Okay, so we're going to actually, this is going to actually be our graph here. So this is my axis here. Okay, so this is t, not x, we're going to use t, and this is our height, ht. Okay, so this is 0, so we could just say this is 1, this is 2, this is 3, 4, 5, 6, and so on. Okay, and then, so that can be time up to 7 minutes there, so this is our time. Make sure you put your label on there, we're reading that in minutes. And then, this is our y-intercept, okay? Remember when there's no letter, there's a t here, there's an h here, this is a constant. That means that is the y-intercept. This is in the form y equal mx plus b. Okay, we're just using x and t, and then you have your y-intercept is 300. Okay, so that's 300. So we're gonna figure out what we're gonna do here. All right, so I think we can do, let's see, 100, 200, 300. Yep, that'll work. All right, so we're gonna say our 100s here, and then so this is 50, 100, 150, 200, 250, 300, 350, 400, and then we'll put up 450 here, just so we can see it. Okay. All right, and this is in meters. Okay, so normally we write this like this, so this is in meters. Don't forget your labels, please. Okay, now this is going to be a little tougher to graph, like with the rise over the run, because we're kind of by 50, so 40 is going to be about right there. So your approximations are going to be a little off. So what you can do is you can just plug in your numbers here. Okay, so if I wanted to do 0, then that's 300. If I put in 0 for t, 40 times 0 plus 300, and that's going to be 300. So that's my starting. Okay, then normally I would do up 40 and over 1. Okay, so actually maybe that would work. So this would be my slope right there. So this would be my slope, which is equal to 40 over 1, which is my rise over my run. Okay, so let's see how this will work. This might work okay because we're at 50. So 40 is going to be right about 1, 2, 3, 4, 5. Right about there. Okay, so that's going to be about 340 because that would be 2, 3, 4, 5. That's a good distance there. This is going to be approximation. So then I just go over 1. So I go here. Okay, so then I do the same distance. So I go up to here. And I move over 1. And I go up to there, and I move over 1. And up there, and I go over 1. Okay, so then I've got a nice line there, and we want to use our straight edge and connect that. So we have, let's see if I can get a smaller ruler actually. Okay, so that's not too bad. Okay, and if the dots aren't on there, you just make them a little bigger when they're on there. There you go. So then this is h equals 40t plus 300. Okay, so that's my graph right there. Okay, so that's not too bad. Alright, so then, this is part B. Okay, so then let's look at part C. So I interpret the intercept at which the graph intersects the vertical axis. Okay, so my vertical axis is up and down. Okay, so intercept, all right, that's actually my h-intercept. So to this problem, this is the h-intercept. Okay, please get in the habit of writing this as a coordinate. It is 0, 300. Okay, and so that's what that is there. And it says interpret what this means, okay? So this means it was starting, the starting elevation was, whoops, that's not what it was 300 meters at time 0. That's what this means. It's the starting elevation was 300 meters at time 0. Okay, so that's that ends question C there. Okay, so we're going to move on to the last parts, D and E. How many minutes will it take to reach 1,380 meters? Okay, so this is part D. Okay, so again, we want to put down our equation. Okay, and so how many minutes will it take to reach 1,380 meters? So at h equals 1,380 meters. So we want to know what this is going to be here. Okay, so we want to know what t is. So h is equal to 40t plus 300. And I was going to put in 1380 there. So let me go ahead and do that right there. So h is 1380. Okay, so then I'm just going to solve my small algebra problem here. So subtract 300. And I get 1,080 is equal to 40t. Divide by 40. Okay, you guys can probably do this in your sleep. So then this is 27 is equal to t. What does this mean to the problem? Okay, so the height is 1,380 meters at 27 minutes. Then we look at part E. What is the elevation of the balloon after 2¼ hours? What are we working in? We're working in minutes in this problem. So we need to convert our hours to minutes. Watch out for that first. So 2¼ hours is equal to how many minutes? We need to know that first. That's going to be your error there. So 2 hours, okay, is 2 times 60, so that's 120 minutes. Then I got an extra ¼ hour, okay, and our ¼ hours are equivalent to 15 minutes. So when I take these two and I add them together, I got 120 plus 15, so that's going to give me 135 minutes. Now I'm in minutes, now I can use my equation. Okay, I'm going to scoot that up here, so I've got h of I was going to write h of t in function notation, but not quite there yet, so we didn't do that the whole time. So I'm going to write h equals 40t plus 300. And then now we're doing it at t equal to 135 minutes. Okay? So h equals 40 times 135 plus 300. So h equals, I did this already, that's 5,400 plus 300, and that gives me my total of